So welcome back. This is our third panel and final for the Big Top event. We're going to be discussing material assessment. One of the things we like to think about is like where we can make the choices in the supply chain. And so for a designer or manufacturer, where are they able to intervene in material choices made within the supply chain?
So probably the best place to think about intervening in the system, in a supply chain system, is to start with what function are you trying to achieve with the chemical or material or product that you're looking at making in the least toxic way possible. So, but not only do you think about that up front so that you have the widest range of options in terms of chemicals, materials, processes, manufacturing to achieve the desired performance function, but you should also keep checking through the product lifecycle to make sure that you're still keeping the lowest possible toxicity, the most benign choices in your materials and processes.
Yeah, when you think about starting up front, it actually opens up the universe of solutions. So if you take, for example, the desire to remove toxic flame retardants from printed circuit boards, you could think about replacing the current regulated flame retardant with one that's not yet regulated, but is still reliant on halogens. That's likely to still be toxic, and so you might want to do a little more work. You might want to take that same flame retardant, turn it into a polymer so they can't make it out during the life cycle of the product, so it will protect people, but it may still be bad for the environment at the end of life. You could do even more. You could think about what are the new materials. In fact, at Safer Made, we've worked with a couple of companies, both Kenora and Melinda, who are making brand new materials that could make more efficient, safer printed circuit boards and do so without the need for a toxic flame retardant. So you can take different approaches, and they take different amounts of skill and different amount of time to come to fruition. But as long as you do, like Ann said, and continue iterating on that question of function and performance, you're most likely to find a good answer that's better for green chemistry, better for the circular economy.
So when we think about material decisions, a lot of times we think about green chemistry. So can you talk a little bit about the growing importance of green chemistry and these material decisions in the public and private sectors?
Yeah, I think there's both push and pull for green chemistry. So you see the push coming from things like greater regulatory awareness about chemicals of concern, either for human or environmental health. And you also see a huge pull from consumers. People want to bring products into their home that they feel good about, that they feel good giving to their kids, that they feel good sharing with their family, and also that they feel good will not impact the quality of life for future generations. So there's both a push and a pull aspect here.
Yeah, and one of those consumer interventions that everyone probably knows about is BPA. People started to become aware of the concerns around BPA and its effect on the endocrine disruption. And so companies started to notice that, and they got push from their consumers to start to substitute that in their materials. And then there's also a push from the private sector. Millipore Sigma, which is a big manufacturing entity, is looking into specifically the 12 principles of green chemistry in order to try to mitigate hazards and environmental impacts around the manufacturing of chemicals.
There's another big driver that's on the horizon, very close on the horizon, and that's us transitioning to a post-petroleum economy, because a lot of the materials that we work with are sourced from petroleum as well as fuel. So as we shift to non-petroleum and renewable sources for fuel, we also need to switch to that for material sourcing.
That makes sense. And so Justin, you mentioned the 12 principles of green chemistry, and there's also other tools where we can address the hazards of materials. So life cycle assessment, hazard assessment. Can you talk a little bit about what kind of support would be needed to actually make those tools more effective in driving change?
Yeah, I think we first of all need better standards and better definitions. I think it's a little unclear to people these days what green and sustainable means. There's a term called greenwashing because a lot of those things have become unclear. And so materials developers would benefit from frameworks that were consistent in their standards and had metrics that were allowed for easy comparison. We also need to think about the fact that a lot of these decisions are value judgments. Mm-hmm. And so you also have to think about, even though different people might be assessing a material in a different way, you have people that look at risk assessment. A lot of people look at the inherent hazard of a chemical. But you have to think about what the trade-offs are. And for example, if you're thinking about formaldehyde in baby shampoo, for example, there's more formaldehyde in a pear than in baby shampoo. That was recently in Johnson & Johnson's products, but they made a decision to get rid of it because there's different exposures to formaldehyde in different areas, and it's a carcinogen. So you have to sort of make a trade-off and think about the vulnerable populations, and the vulnerable populations could be exposed to just minute amounts of carcinogens or endocrine disruptors, things like that. So you have to make decisions around that as well.
So some of the issues that we've seen in terms of trade-offs and impacts are things that we need to keep in mind as we think about avoiding those in the future. We've had shifts. We go from impacts on one environmental medium to another. We think about MTBE. We're trying to solve an air pollution problem, ended up contaminating water. Very often we try to solve environmental issues like CFCs, taking CFCs out of cans as propellant, and we end up putting things in there that have impacted worker health, for example. And so that's something we need to keep in mind, that there are some trade-offs that we should not allow to happen, that we've had long-term impacts on human health and the environment, and those are things we need to keep in mind now as we choose safer alternatives, that we don't want to continue those errors or make those errors worse than they have been.
And to avoid regrettable substitutions, it's important to look throughout the life cycle so that you're protecting not only the user, but also the people near where the raw materials are made, who are dealing with it at the end of life, and to really understand where are you today, what's the baseline, and how can you improve.
Yeah, I think that's a really good point, thinking about not wanting to offset harm to another product life cycle when you're making these decisions. So while the support's needed, and so driving towards a more effective system, consistent metrics, consistent standards, who are some of the players that this would affect? Who would be using these tools or making these decisions within products and materials?
This is one of the challenges. You have to make tools that appeal to very different sorts of experts. So you have people making material selection decisions. You might have a designer who's making apparel, or you might have someone who's putting together a formulated product, something like a shampoo. You might have someone who's an industrial designer putting together material and choosing. So these are people who need to be able to compare a bunch of materials and say, what do I want for the right performance and benefits for the environment and life cycle. At the same time, you need information for chemists and experts like myself who are trying to say, all right, what are the new materials that are needed in the world? What function and performance do they have? I want to know things at a whole different level rather than choosing, component A versus component B. I want to know what all the molecules are. I want to know how they're made. I want to know where they go in the environment. And so there's a lot of information here, and you need to be able to assess it and access it at different levels.
So some of the other folks that might need to access that information are regulatory agencies who are making sure that public health and the environment are sufficiently protected, and so they need to be aware of that. And then more broadly, groups of stakeholders, people who are going to be in the communities outside factories, people who are in the working population that will be exposed to a new chemical or material or process. All of those folks should be considered as well in these discussions. They may not need the information to the same technical level that Marty's talking about for a designer or a chemist, but they should also be brought into the conversation.
Yeah, so it seems like there's key concepts and needs for developing those frameworks and consistency across looking at the micro level as well as the macro level of products and materials. So thank you guys for that. That was our third and final panel. Thank you for viewing. Check out our other first and second panels that are also part of our discussion.